Hello, Advanced Algebra 2. Welcome to the Concept 29 Notes, Part 2, Sequences and Series. And now we're going to look at summation notation. We've been talking about sequences. Now we're going to look at a series. So when the terms of a sequence are added together, the resulting expression is a series. A series can be a finite can be finite, it can have an end, or be infinite. So notice we have the finite series. We mentioned it before in Part 1 notes, 2, 4, 6, and 8. And then the series of this, if we added it up, now we can write it in summation notation. So for both series, the index of summation, n, and the lower limit is 1. The upper limit is 4 in this case because there are 4 terms. So summation notation is also called sigma notation. So what you see there is the Greek letter sigma, and that indicates sum in math. So the number n equals 1, and then the number below the sigma and above the sigma tell you how many terms there are. So we start with the first term and continue to a fourth term. And then what you see to the middle right of the sigma is the rule for this to generate each term in the sequence in terms of the position number. So we take 2 times 1 for our first term, 2 times 2, 2 times 3, etc. Now for an infinite series, notice that our top limit above the sigma is positive infinity. So let's look at example 3 and just write some of the summation notation. So let's number our terms in 3a. So we have 1, 2, 3, and then I notice that I have a pattern here thinking in terms of the n number. If I take n times 25, I can generate the term in that sequence. Or in this case, it's a series because we're adding them up. So I know that 250 would be the 10th term because 10 times 25. So now I know the beginning number of term, which is 1, and the ending, which is 10. And I know the rule because I can see what's happening mathematically. I take 25 times that position number n. Now this is for B, we have an infinite series, and so I'm going to keep going to infinity. So I'm going to write my sigma. My first term is 1, and then my top term is infinity. And then I notice just a relationship between those terms is if I take my position number n and put it over n plus 1, that generates my terms in my series. Now we're going to find the sum of these. And so notice in A, we have a series that ranges from term 4 to term 8. So I'm going to plug in 4 and then 5 and 6 and 7. So 4 squared is 16 plus 3 is 19. 5 squared is 25 plus 3 is 28. 6 squared is 36 plus 3 is 39. 7 squared is 49 plus 3 is 52, and on to 8. And then I add all those up, and so finding the sum of the series equals 205. Now in the examples before, we were just writing the series in summation notation, but here we're actually finding the sum. Let's do the same with B. So notice that our terms range from the first term to the 5th, and we're taking 8 times that term number. So we'll get 8 times 1 is 8, times 2 is 16, times 3 is 24, and on to times multiply by 5. Now we'll add all those up, and that will give us a sum of 120. C is a special kind of series. So notice that we are just taking the number 1 and adding it 14 times. So that would just give us that top number 14. Over in the right-hand box, you can see the formulas for there. Now D, we have a series where we're just adding up the position numbers. So 1 plus 2 plus 3 plus 4 all the way up to 6. There is a formula to find that. I'm just going to go ahead and write out my number of terms because it's a finite series and it's not going to take me long. Then when I add all those up, I end up with the sum of 21. All right, it looks like I need to wrap up the notes because people are back in class, but we are finished anyway. So this concludes Concept 29, Part 2 notes.